Let's look at another example of a stoichiometry problem. The decomposition of sodium azide, which is NaN3, rapidly produces a large volume of nitrogen gas. It is used in airbags in trucks, cars, and even some planes. Which plane is best for finding the mass of N2 produced from a given mass of NaN3? We identify the starting point, which is some mass of NaN3. We aren't given a specific value here, but we're not actually solving the problem yet. And we look at what we're trying to find, which is the mass of N2. I know that I have to start with grams of NaN3 because that's my starting point. And I can go from grams of NaN3 to moles of NaN3 to moles of N2 to grams of N2. So A is the correct answer. When I look at B, notice that it goes from grams to grams, as well as C going from grams to grams, but we have to have a mole to mole ratio to get between two different substances. From D, we only have moles of NaN3. It doesn't relate to the moles of N2 that are needed. Same setup. What is the molar mass of N2? Each nitrogen has a mass of 14.10 grams per mole. We need to multiply that by 2 because the molecule exists as N2. The molar mass must match the formula. Notice we don't put the coefficients in there. That's taken care of in the mole to mole ratio. We're just looking at the formula of the compound. So we get 28.02 grams per mole. Now, how many grams of nitrogen are produced from 10 grams of NaN3? First, we need to see if the equation is balanced, and when we check through, we see that yes, it is in fact balanced. We know the molar mass of N2 is 28.02 grams per mole. We did that on the previous question. And we can find the molar mass of NaN3, which is 65.01 grams per mole. Now we look for our starting point, which is our 10 grams of NaN3. We need to convert this to moles so we can use our mole to mole ratio. Therefore, we get 65.01 grams per mole of NaN3. Cancel out grams. Next, we have 2 moles of NaN3 to 3 moles of N2, and that mole to mole ratio comes from the balanced chemical equation. Moles of NaN3 cancel out. Now I can go from moles of N2 to grams of N2, and I use the molar mass, 28.02 grams per mole of N2. Moles of N2 cancel out, and I'm left with 6.47 grams of N2.